Hi everyone, I am Dr. Anindita Rai Choudhury. Today I am going to discuss about how to write and run first simulation script in NS2. What is NS2? NS2 is Network Simulator 2, by which a program models the behavior of a network. Now, before we start writing script in NS2, we should understand the following things. The first thing, which is very important, that is initialization and termination aspects of network simulator. Now, the second point is how to define the network nodes, how to create nodes, how to link the nodes, and what about the queues and topologies of the nodes. Now, defining the agents and their applications, and about network animator, that means NAM, and what about the trace file, or what is the tracing. Okay, so one by one I will describe. Now, how to create a simulator object. So whenever we will write a program, the first line will be the set NS new simulator in bracket. Okay, here NS is a variable initialized using set command, and the code in bracket new simulator is an instantiation of the class simulator. Now, always remember that here simulator, the first character S will be capital letter because simulator is a class name. Okay, so we can call all the methods, that means the member functions of class simulator, using the variable NS. Now, creating the output files. Here two type of files will be required. One is the NAM file for visualization. Here we have taken the variable NF and the name of the file where it will be saved is out.nam, and we are connecting this with the member function nam trace all. Okay, the same thing is for another file, trace file. Here the name of the trace file is out.tr. Here also we are connecting this using the function trace all. Okay, so nam trace all, this is the member function of the class simulator. Now, how to create nodes and how to create the links between the nodes. So here I have taken very simple example. I am creating only two nodes, N0 and N1. Okay, so here we are creating two objects. One is N0 and another is N1. So now we will see how to create objects. So first we will see that here the two objects N0 and N1 is created using the syntax set N0, then within third bracket the $ns node. Okay, in this first line you can see that NS is the we can say the variable as the NS simulator object instance. Okay, so this variable NS will be used throughout the program here, and in this particular line we are using that $ns to create nodes using the function note. Okay. So now the second note N1 is created using the same syntax, set N1, then within bracket $ns note. Okay, so here the node is the member function which creates a node using the variable or the instance of simulator class, we can say NS. Now how to create the link between the nodes. Here you can see we can create the link between the two nodes N0 and N1 using this particular line. NS, the type of the link here is duplex link. Then the two nodes $N0, $N1. Then this is 1 MB is the bandwidth, 10 ms is the delay, and drop tail is the type of the queue. Okay. So the type of the queue, drop tail, is actually in the sense that if the packet which is arriving is exceeding the capacity of the queue, then the last packet which will arrive will be dropped. So that's why the name actually drop tail. Now setting the size of the queue of this particular link N0, N1 to 10. Here the size of the queue we have specified as 10. Okay. Now we need a protocol. Here we have chosen the transmission control protocol TCP, and we have created a agent, TCP agent, and attach it to node N0. So this set TCP 0 is the actually the object name or variable name of the class agent slash TCP. This is the class name. So we are creating a TCP agent and we are attaching it to the node N0. Okay. So this particular node N0 will act as the sender node. Similarly, we need a sync node or receiver node. So here we have to create one instance of this class agent slash TCP sync. The name here is sync itself. Now we are attaching this NS using the function attach agent $N1, the node, to sync, through which the node N1 will act as the receiver node. Now we are connecting the sender TCP agent with the sync agent using the syntax $NS connect, then the TCP agent and the TCP sync agent. Okay. So now we need one application of TCP, which is FTP, file transfer protocol. So we will set up FTP over TCP connection. So here see, we are here to set up FTP over TCP connection. So here we have taken set FTP 0 as the name of the variable FTP 0, and here the class name is application slash FTP. So we have created one object FTP 0 and we are attaching FTP 0 with the TCP agent, which is TCP 0. So these two agents are connected with this function attach agent. Now how to schedule this particular FTP application? Here see that we have started this FTP application FTP 0 at 0.5 second and stopped it at 4.5 second, and we have finished it at 5.0, that means at 5 second. So now this finish function is called to finish the simulation. And how actually the finish function works, what happens when a finish function is called, this thing we will be able to know if we carefully see all the lines which is included in the finish function. So in finish functions, we have globally declared the variables ns, nf, tf so that it can be used throughout the program. And this $ns flash trace actually flushes the informations to the output files, two different output files. One is nam trace file out.nam, another is trace file out.tr. Nam trace file is for visualization and out.tr is there to store all the informations of the packets regarding dropped packets, received packets, the type of the packets and all the other informations. I will show it what exactly the out.tr file contains. And we have to close because we have opened two files, the nam trace file out.nam and trace file out.tr. We have to close it. So this close the variable name $nf, close variable name $tf. It closes two nam file. One is nam trace file and this trace file. And for visualization part, we have to execute nam on the trace file. So this exec nam out.nam ampersand is there to execute the nam file for visualization. Okay, so once we call ns at 5.0 finish, this particular line is called automatically. This finish function is called, and all the lines under this finish function is are executed automatically. And to run the simulation, the line which is required is ns run. Okay, so this is how we can create nodes, how we can create links between the nodes, and how we can set the queue type, how we can set the size of the queue, how we can choose a protocol like transmission control protocol, which is a connection oriented protocol. And since this is a connection oriented protocol, we need bidirectional link for acknowledgement. Okay, so here we have taken, if you just concentrate on the link type, you will see that we have taken the link as bidirectional link, duplex link. Okay, here this is duplex link. So and one of the application is FTP file transfer protocol. So we have taken the agent of this one also and attach this particular FTP agent with the TCP agent. Okay, so setting up FTP over TCP connection to get the services of this FTP application. Okay, now we will run this particular program and we'll see what exactly it shows after simulation. Okay, now we will run this particular program where two nodes are created and link between the two nodes are created. We have taken TCP as the protocol and we have taken the application FTP. So we will run this program. So let's run the program. In this particular example, I am running this program in Windows 7. Actually, in Windows 7, I have installed NS2. So here the command is same, whether in Ubuntu, whether in Windows 7, whether in Windows 10. The simple command is ns, then the name of the TCL file. So the name of the TCL file here, we have seen that here the name of the file is simple program. Since we have taken TCP protocol, so I have given the name tcp.tcl. So once I run, see here the name is there to show the visualization part. The simulation part is visualized using the out.nam file. So once we run, it shows the visualization or the simulation between the two nodes N0 and N1, and this is possible using for the file actually the out.nam. If you can remember, two files we have used as the output files. One is out.nam and another is out.tr. So this out.nam file is actually responsible for this visualization part. So here in this particular window, the edit option is there for change the layout. For the time being, I am not actually entering into that part. Only I am showing the simulation between these two, communication between these two nodes N0 and N1. And once the simulation will be over, we will get another file which is out.tier, and out.tier file, from the out.tier file we will get the number of packets dropped, the received, the packet type, size, source node, destination node, all the informations regarding the packets. So this out.tier file is also very important. So once the simulation will over, we will open the out.tier file to see what exactly is there in the out.tier file. Okay, so almost it is done. So we will now see the out.tier file. Here already I have opened the out.tier file previously, so once I will click, it will give you the option of reloading, because it is changing the existing out.tier file. Once I do some simulation, it overwrites the existing out.tier file, because I have given the conventional name of the output file as out.tier file. Later on I will show how we can change the name of the output file related to our program. Okay, so for the time being, just out.tier file. This is the file where I can see that several informations are there, and each and every field has specific meaning. Now I will describe the meaning of this particular file. And so this is the trace analysis, or we can say the analysis of the file of the out.tier. So the first column represents the event, like whether it is received, whether it is NQ, whether DQ, whether dropped. The event actually is indicated by the first column. Next, the time. Second column indicates time. Then the from node. Here the node from node is 0, to node is 1, because sender node is 0, receiver node is 1. Then the type here is TCP. Then the size of the packet. Since we have not set any flags, so it is showing dash dash dash. We have not set any FID. FID is very actually important, in the sense if we want to differentiate the flow, one flow from another, and give some color to each and every flows, then FID we can use. Then the source address, destination address. Source address is represented using node.port, and also destination address node.port. So here source address is 0.0, and destination address is 1.0, because only two nodes are there, N0 and N1. So if I want to summarize, then the first step here is to create the simulator object using NS variable name here we have used. Then new simulator. Simulator is the class name. We are creating object or instance of that. We have created two or opened two output files, out.nam, out.tier. We have created two nodes, N0, N1. We have created duplex link between the two nodes. We have set the size of the link. We have taken TCP, transmission control protocol, as the protocol. Here we have created one agent of this TCP agent. And since TCP requires bidirectional link, so we have taken duplex link because it has acknowledgement, so bidirectional link is required. And the service which we have taken here is the file transfer protocol, FTP, of the TCP. So we have created the agent of these two and attached them. Okay, and we schedule the FTP applications using FTP start and FTP stop, and finish the procedure using finish function. In finish function, we have closed all the files which we have created, the output files. The NF is for nam trace file and TF is for trace file. We have closed two files. We have flashed everything to the output files, and we have executed the nam file on the trace file to show the visualization. It is actually very important. Okay, so in this particular example we have taken TCP as the protocol, but we can take also UDP as the protocol, And if we take UDP as the protocol, then the application which we will be using will be the CBR. I quickly will show the program that here we have taken the same thing, UDP, using UDP protocol, agent UDP, and the application which we have used is the application CBR. Okay, so this is also possible. If you take UDP, you have to take the application CBR. So in next video, I will try to show you another program using UDP protocol instead of TCP, and will take service from CBR. The application will be CBR. Okay. So I hope now it is clear to you how to create nodes, how to create links, how to take a protocol and the applications of it and run using the network simulator 2. Okay. Thank you. Thank you everyone. Thank you for watching my video.